Today's topic of discussion is petroleum refinery relocation to a developing country. This is the case study that I would be doing it for you guys. My name is Rafiq Khadimally, and I am going to make this presentation for you right now. And this is basically 5 phases of project management which are required in a petroleum refinery relocation project. And this is basically a case study that I have done on a 100,000 barrel refinery. And this basically also talking about the three key words that what we are talking about. We are talking about a surplus and a foreclosed plant, and we are talking, which include, by the way, this is a case study for refinery, but it could be for any plant like petrochemical plant, a sugarcane ethanol plant, or an power plant, industrial plant, anything. And it is relocation to a developing country. The key message basically is that the surplus plant, the selection of a surplus plant is very important. What vintage it has to be, whether it is unused surplus or it is a foreclosure. Obsolescence could be technological, operational, legal, economic, or many times the operators cannot afford this thing. Okay, so that thing happens quite a bit. They cannot afford. They don't have the budget to improve the plant or to do some upgrades, then they have to close this plant. Okay. And a typical refinery consists of a process area, okay, which includes all the columns and, all the exchangers, towers, fin fan coolers, compressors. That is basically the process plant. And then you have a control room somewhere. Then you have a utility area. Then you have got a storage tank farm, okay, where all the crude comes in. Then you have got the rundown tanks, and then you have the finished product tanks. And then you have the sales area where you have the loading arms, okay. Then you have maintenance workshops. You have the stationary equipment workshop. You have rotating equipment, E&I, piping, all those workshop areas, civil workshop. You have the fleet of vehicles, cranes, hauling equipment, and what needs to be relocated from one place to another. That is a very big decision which the project manager takes. Okay, and I am going to have a pictorial basically on this one, which I am going to be showing in a short while, how a refinery is, and we follow the project management body of knowledge. I am a PMP, project management professional, and I follow the project management body of knowledge, which is PMBOK. And we have got initiation, planning, executing, and controlling and closing. Okay. We have got 5 processes: initiation, planning, execution, monitoring and control, and closeout. And then we have got the petroleum refinery triangle. And this triangle basically is the technology, you have the EPCM, and you have the operation. This is the triangle with which a refinery runs safely. So an existing refinery is original refinery. This is the way it is running. But when it is relocated to another place in a developing country, that triangle has got to be followed. Okay. I'm going to show you the slide on that one. And then we have got the 5 phases of project development execution. You have concept and initiation, you have feed, the front end engineering design, you have EPCM, engineering, procurement, construction management, you have systems completion, which is basically pre-commissioning and commissioning and then delivery. So after the concept and initiation, you have the FID, which is the final investment decision. Then you have feed, then EPCM, then you achieve mechanical completion. Then you go for pre-commissioning and commissioning, and then you have to have the ready for startup. Okay, So now I am going to be showing you, I'm going to share the screen with you right here. And in that way, then you would be in a better position to look at it, what we are talking about. Okay. So give me a couple of minutes, just not couple, right here. And I'm going to be sharing the screen with you. And it is right here. And I'm going to blow it up right here. So you are able to see that. Okay. And this is what I'm talking about, right? Petroleum Refinery Relocation Project. My company name is Houston Consulting Group. Okay. Rafiq Khadimally. And I offer to be client's engineer, which is also called owner's engineer, which means any conglomerate in a developing country, if they need a refinery to be relocated, they are going to hire my kind of a consultant. And I'm going to advise him, guide him all the way through. I'm going to pick and choose an EPCM company. I'm going to pick and choose a project manager alongside with the client. That is going to be my role. Okay. It's a case study. It is a presentation on a 100,000 barrel refinery. And we always start with a safety moment. And today's safety moment is about reporting the near misses. Like, for example, you're coming down on a stairway and you are not holding the handrail and you're about to stumble. That is called a near miss. So a 600 near misses results in one death. So you can always eliminate it, okay, by this safety moment that I have presented for you. And we have a mission and a vision statement. Mission statement, we are dedicated to delivering effective, efficient, respectful, quality, and conforming to health, safety, and environment, the projects with integrity and accountability using both the proven and innovative methods. And the vision statement for us is to make the world the place of choice to live and grow. Okay? And what is this about? Abstract and summary. So we have got three keywords here. We have a surplus and a foreclosed plan, which includes either refinery, petrochemical, power, or industrial plants, and the relocation to a developing country. Okay, and then we have got some pictorial illustrations. The key message and the abstract is the selection of a surplus plant is very important. What year it is, vintage, you're not looking for a corroded, whether it is unused surplus, foreclosure. Many times the foreclosures are due to obsolescence, which could be technological, operational, legal, or even economical. And many times when a plant needs to be, it demands for upgrading, they don't have the funds. What they do, they foreclose it. Surplus plants are most economical and picture perfect solution for developing countries to take the advantage of cost and schedule savings. Okay. And we, Houston Consulting Group, offers project interface management to the clients in developing countries with the role of client's engineer or the owner's engineer. That is going to be my role in this one. Now, summary is USA, first of all, excels in defect-free project management to clients in selecting the suitable plants, the EPCM, engineering, procurement, construction, management, project manager, three-dimensional laser scanning, which is the match marking, okay? Dismantling, transportation, free on board, shipping to the port of disembarkation. And then from there, you have to have it moved now, the training of the client's operator team. Then in that country where it is going to be relocated, there are requirements for local content, which means the local contractor has got to be picked up to do this job. So from the developed country where the refinery is going to be relocated, there will be a PMT, the project management team only. That is very important, that what I am talking about, okay? So this is what I am going to do now. Okay, So those would be the project manager, the quality, HES, the health safety, and engineering manager, construction manager, system completions lead, and all that. You will see, I'll show you the org chart, which I have drafted out for you, that would be the one installing the refinery, that one, okay? So you would be needing to train the client's operator team, contractors for local content, arrange transportation from the port, decreate it, reinstall it at the place, start up, operate with the spares and the OEM warranties. OEM, original equipment manufacturer's warranties. That is very important, that the place where the refinery has been relocated, that all the pumps and compressors and all those have got warranties have been extended. Okay, what a petroleum refinery consists of for a relocation project? First of all, in a refinery, you have a process area. It includes crude distillation tower, crude charge pumps, rundown pumps, vessels, splitters, towers, columns, heat exchangers, fin fan coolers, compressors, structures, various units, reformer, vacuum units, coker, etc. and etc. Okay? And then the control room, where everything is in the control room, where the operators are managing the running up of the plant. Then you have a utility area which has got boilers, separators, API separator, CPI separator. CPI stands for corrugated plate intercept, okay? And PPI is parallel plate intercept separator. Water treatment plant, desalination unit, depending upon if the refinery is close to the shore, air compressors, etc. Okay, that is. Then the second one is the storage tank, the tank farm area, which includes crude oil storage tanks, crude receiving facility via pipelines or by trucks or both. Then pig receivers, which will measure the quantity, the rundown tanks, petroleum product tanks, sales tanks, LPG bullets, and spheres. Then we have got the sales area where we have the loading arms, petroleum product sales, truck loading facilities, loading arms, meter provers to ensure how much quantity you are selling. Then in the refinery, you have a maintenance workshop. You have piping and mechanical workshop, which is also the stationary equipment workshop. You have rotating equipment, pump and compressor shop. You have E&I, electrical and instrumentation and control systems workshop. You have got civil engineering workshop. You have the fleet of vehicles, cranes, and hauling equipment, all that area. And then what needs to be relocated? That is very important. You don't take the storage tanks relocated from one place to another. Some companies have done in the past that they cut the plates at the weld joints and they stack them up. They took that in that country, rebeveled them, and rebuilt the storage tank. That has happened. But take my example on that one. In a relocated refinery, you take the process, the important parts, the important components, equipment, build your own tank farm at the relocated place, unless the pros and cons are determined by that. So what needs to be relocated is a decision to be made. All process equipment will be relocated. Large storage tanks will not be relocated. The project manager reviews the pros and cons to decide what will be relocated, small tanks, spheres, and bullets, etc. And then they have a list of relocated equipment that has got to be made. Another important thing is about the control system. Whichever control system you have, Foxborough, Emerson, or whichever in an existing refinery, the original refinery, when you relocate it, you have to renew, you have to throw all the instruments away. Take my example. Don't ever refurbish your control system on modern lines. The most modern, because control system is the brain of a refinery. Understood? Okay. Now we are talking about the organization chart. Look, where is the client on the top? Right there. And did you notice the owner's engineer, yellow? I'm right there. This is my role. I'm the advisor to the client from cradle to the grave, all along. Am I the project manager or the project director on the job? No. I would be hiring the EPCM company, the project manager for the client. You got now my role? I'm the advisor. I'm the consultant. I'm the one advising the how the refineries have got to be selected, which one needs to be picked up and how. Okay. So directly under on one side, you have a surplus refinery. You have to locate that, and I help that out also. We would be having a 3D scan company, three-dimensional. These days, they don't paint mark A and cut the pipeline in between, and then at the relocated, they connect A with A. No. Now it is done by scanning. It is three-dimensional scanning with which it is done. The dismantler group, and then the shipping. Okay. So when the client hires me, I advise him that how I'm going to be choosing an EPC company on a multi-bid basis, okay? Because they are going to be the one doing the feed, they are going to be the one detail engineering, they are the one, and the selection of project manager is very important. The engineering manager is very important. The operations manager is very important. The safety manager, the quality manager, the procurement manager. This is the first line, I call them PMT, Project Management Team. This is the team which will go to the relocated place. You think a welder is going to go from America all the way to a developing country to weld it? No. You understood? That will be the local contractor, who again I am going to be advising the client, who the local contractor has got to be. My role is a consulting role, interface management, owner's engineer, client's engineer, from cradle to grave, A to Z. I'm there all when the project starts until it is running, and even beyond if the client would like to, keep me with themselves. So look what we have got here now. We have the engineering manager, and then under him we have a structural, E&I, control systems, mechanical and piping and process. Okay, and then we have got project controls group and the process and the procurement lead. We have HES, health, environment and safety, QA/QC, the construction manager, the completions manager, and ops manager, operations managers. Now I have got a pictorial presentation on this one. So look at it on the left-hand side. I've got USA. It's a hypothetical case that a plant is available, which is the origin USA. And right here, the refinery is there, and then double arrow shows that it is moved from there to the port of disembarkation. I'm sitting in Houston, so I use this example that the port of Houston, so refinery at site, laser scanning, match marking, dismantling, crating, and transportation free on board, FOB, to the port of embarkation. Okay, so here we have E for that one. Then comes the shipping part of it. In the shipping, FOB is free on board. Ship is going to be, they're going to lift it and place it on the ship. You have to pay for insurance and freight. Then what it becomes? It becomes CIF, cost inclusive of insurance and freight. And it travels to the developing country on the right-hand side. The port is the port called the port of disembarkation. That's why it is called D. The Houston port, as an example, was E, right? The port of embarkation. What is going to be here? We have the destination there, developing country, refinery, shipment, CIF, cost, insurance, and freight. At the port of disembarkation, local transport to the relocated refinery site. You decrate it, You reinstall it, you do the mechanical completion. You have systems completion, then pre-commissioning and commissioning and ready for startup. And startup, you operate with spares, with OEM, original equipment, manufacturer's warranties. You train the operators there, you maintain it and deliver it. Okay, here we follow PMBOK, which is the body, which is the father, daddy of project management. I am PMP, and this is the courtesy of PMI, Project Management Institute.org. PMBOK stands for Project Management Body of Knowledge. So we, all the PMPs, that's the way we execute our projects, that we follow the principles of PMBOK, okay, which basically is initiating, planning, executing and controlling, and closing. This is called PMBOK processes. And the project life cycle exactly in the same way, how the project starts, initiated, executes it, and then it closes down. There are five basically processes which we have got: initiation, planning, execution, monitoring and control. Monitoring and control right here, you could reiterate both ways. You could go towards execution, you could go towards planning. So it is an iterative role at that time, and then you can close out. Okay, now I'm talking about the so-called petroleum refinery triangle. Remember one thing: an original refinery operates safely with extensive coordination within the technology group, just like UOP, the EPCM group, just like Bechtel, and the operator of the original refinery, just like Exxon or Shell. So look at the triangle. I have technology on the top, I have EPCM on the left-hand side, and then I have operation on the right-hand side. This is basically the petroleum refinery triangle with which the refineries work in a safe way. What I'm trying to say is, when you are going to relocate the refinery to another place, you have to have the similar petroleum refinery triangle maintained there, involving between technology, EPCM, and operations group. So look at the right-hand side, which is in blue. Relocated refinery. Similarly, for a smooth and safe operation of relocated refinery, they must maintain the same configuration with technology groups, the EPCM, and the operator of the relocated refinery. And look, this is a triangle right here. So this is my pictorial way, and then I show the arrows coming from a developed country to a developing country. You got it? Okay. Now I am talking about project development and execution. 5 phases. Okay. The first phase is basically in this diagram. On the left-hand side is concept and initiation. After that, we have FID, which is final investment decision. Okay. Then we have got FEED, and FEED stands for front-end engineering, which is phase 2. Then we have got EPCM, engineering, procurement, construction, installation management, which is phase 3. What we come at the tail end of it, we come to what is called mechanical completion. Then we go into systems completion, which is pre-commissioning and commissioning, and which is phase 4. So phase 2, phase 3, and phase 4, these are the major activities where all the nitty-gritty is happening. And then the phase 5 is delivery. So if you start from there, review from concept and initiation to FEED, to EPCM and installation and the mechanical completion, then systems completion involving pre-commissioning and commissioning and RFSU, which is ready for startup, then operations and startup, and project delivery. Okay, and concurrent engineering is always ongoing, that saving man hours and schedule. By the way, locate my presentation, Interface Management Energizes Concurrent Engineering on Mega Projects. that is applicable on all the projects. So interface management has energized concurrent engineering. Concurrent engineering is many discipline engineering working at the same time in liaison with each other. Okay, that you save the man hours and you save the schedule. So here we are now, the details of each of those phases that I'm talking about. Concept and initiation, which is phase one. Review all documentation, plant capacity, process, equipment, previous turnaround reports, any planned plant upgrades, potentials to incorporate new technology, finalize bill of quantities, originate OEM, which is order of the magnitude estimate, finalize the BOD, which is the basis of design, feasibility report, generate proposal for FID, the final investment decision approval. So concept and initiation stage, the end product is FID, final investment decision. Okay. Then we have got feed, and the feed is going to be starting by the EPCM. So after FID approval, initiate feed, full and detailed review of all documentation, review crude oil composition, revise HISIS analysis as needed, heat and material balance if you want to increase it, revise process narrative. You wanted to revise the capacity of the plant. If there are upgrades, you include all the recommendations coming from the last turnaround of the refinery when the refinery was foreclosed. Then you revise the PFDs. You revise the process narrative, revise the capacity, of maybe sometime it's a 60,000 barrel refinery. Right at that time, the owners say, we want to add 20,000 barrel also. So you go back to the engineering company, the technology group, and get, so at the time when the refinery is relocated, it is 60 plus 20, it is 80,000 barrel refinery, okay? Just to give you an example. So you revise the process flow diagrams, the mechanical flow diagrams, they're also called PNIDs, equipment list, line list, cause and effects. Now you freeze the design, okay? And you conduct HAZOP. What is HAZOP? Hazardous operability analysis. By the way, any relocated refinery project, treat it to be a new project. Do not cut corners. There have been explosions in many relocated refineries because they cut the corners. So hazard operability analysis has got to be done, completed as if you do in a new built refinery. The only difference between this, you have the equipment available, you have the technology available. But when you are taking it to another place, as I mentioned to you, you are replacing the control systems completely. You're not going to take the old instrument, throw them out. Old instruments are out, and you go with a relocate new system. There may be many technology developments in Foxboroughs, Rosemounts, Emerson, whichever system you, Honeywell, but make sure relocated, or a petroleum chemical plant or an ethanol plant, you are relocating it. You throw the old ENI, the instrumentation, you go with everything new. That will ensure that your plant is relocated in a proper way, okay? And you are ready now for EPCM phase. And let's call this phase as F. Now we are talking about EPCM, Engineering, Procurement, and Construction Management. After FEED, the EPCM project manager to award all contracts via multiple bidding procedure and detailed engineering, procurement, construction, and installation to respective local contractors and supervise via PMT the execution of project refinery location project, generate approved for construction drawings, detailed specs, shop drawings, perform QA/QC procedures, HES practices on construction and installation as laid down in detailed specification, and achieve what you have to achieve now at this phase, mechanical completion. Okay, so this was the phase 3, and let's call that as E. Next phase is phase 4, which is systems completion, pre-commissioning, and commissioning. After mechanical completion is achieved, initiate systems completion with pre-commissioning and commissioning of all systems, equipment, control system. FAT. What does FAT stand for? Factory Acceptance Test. What is SAT? Site Acceptance Test, etc. There are many tests there, by the way. To achieve RFSU. What is RFSU? Ready for startup status, and startup as planned with the operations group. Now the operations group have come into being. And by the way, in all these phases, the concurrent engineering is ongoing. Reviewed my previous presentation on my website, which says interface management energizes concurrent engineering on mega projects. Okay, this phase 4, you can call it S, system completion. Then we are in phase 5, which is delivery. Plant startup with operations group, ongoing training of operators and maintenance teams, workshop for mechanical piping, stationary equipment, rotating equipment for pump and compressors, E&I, electrical and instrumentation, control systems, civil works, fleet of vehicles, plant turnaround management, routine, planned and emergency turnarounds, utilities, some chemicals are used, operating and capital spares are used, generate full as-built drawings, full documentation, and deliver. Let's call this as D. And again, as I mentioned, concurrent engineering is ongoing. The engineers are having a feedback and they are revising the drawings as they are installing them. Okay? And then the overarching phenomenon is value engineering and lessons learned. Apply this overarching and ongoing phenomenon. This is value engineering based on constructability and lessons learned from previous projects and captured continuously at every stage of engineering. So apply them. And again, here, concurrent engineering is ongoing, saving man hours and schedule. So now when you plot them on a full-blown project, it looks like as if it is an Olympiad of project management. Olympics has got 5 circles, which represent the 5 continents in the world, and they are overlapping with each other. We have a similar situation. C is concept, F is feed, E is EPCM, S is systems completion, and D is delivery. So all these circles, they are overlapping each. Between concept and feed, you have FID. What is FID? Final investment decision. Between E, which is EPCM, and system completion, you have got mechanical completion, and it is delivery. So the project interface management is occurring in each phase with value engineering and constructability concepts coupled with previous lessons learned LLs, and depending upon the nature of the project. And that is basically, if you look at it, the outside overarching curve is VE, which is value engineering / LLS, lessons learned. And FID is the final investment decision and mechanical completion. Okay. And this is about me, about the presenter. And right here, again, as I mentioned, Rafiq Khadimally. I am the I'm the owner of Houston Consulting Group. And this is just it's a quite a bigger, but my humble background is over 3.5 decades of work that I worked in the refineries, then I worked in the offshore, and I worked in Aramco Jeddah oil refinery, Petroleum Refinery, and then coming in USA, I worked in La Gloria Refinery in the early stages. Then I switched over to offshore projects, worked for McDermott and SBM Offshore, Chevron on Angola project, and Bechtel. And now at the same time, not only that I'm consultant, vice president or president of the company, I'm also now a visiting professor and teaching the younger generation project management. Okay. If the If there are any questions, then you are going to be, so by the way, now I am going to close this one and then I'm going to be talking to you. Okay. This is going to be uploaded on my LinkedIn. It's also going to be uploaded on my YouTube channel. And it is also, I'm going to copy the links on my Facebook account. Okay. So again, I have made a humble presentation for everybody's knowledge that this is how a petroleum refinery project has got to relook for relocation. This is a series of projects. Basically, I would be making presentation on ethanol plant relocation. Some of my clients have asked me about sulfuric acid plant. Then vegetable processing plant, just like Green Giant I mentioned to you. Another of the client mentioned about the water, the drinking water, just like that, the plant, that's what they are talking about, okay? And tomato ketchup plant also. So any kind of plant. My background is oil and gas, heavily LNG and refinery. That's my background. But when I am doing these kind of industrial projects, relocation to the developing countries, I have picked up all kind of projects, all kind of plants. I'm sitting in Houston. USA is the biggest source of surplus plants that you can see. Even the European Union do not have that many. America has got plants, but this is the selection of the plant is very important. You don't go and put up an old plant there. You have to be, that is what is my function with the client. So I am basically proposing to be the client's engineer or owner's engineer from cradle all the way to the grave, means A to Z, because I would be, along with the client, will be selecting the EPCM company, also selecting the project manager, review their, interview them and all. I have shown in my presentation, you could see what is my role in it. Thank you very much. Please do contribute your comments, and I am wishing you all the best. Bye for now.